So today's lesson is about decimal notation, which is actually the system we've been using to represent numbers since we were in kindergarten. And we might not even realise what we're doing. But we've been using this notation for a long time, so it's second nature to us now. We're just going to take a closer look at it today because it can really help us to multiply and divide by numbers like 10, 100 and 1000. Now, we actually know that the prefix des in the word decimal actually comes from the Latin word for 10. So we can take a guess and say that the number 10 must be pretty important to our place value system, which is the way that we write numbers. So let's take a look at a number, and let's say the number 1111.11. Let's make it really simple. We won't introduce any other digits. We're just going to use ones. Now, we know that this column here, this is the ones column. So that represents units. Now, I'm going to show you why the number 10 is so important. Let's consider the question, how many times larger is the tens column from the ones? So if we go from ones to tens, how much bigger is 10? So how many ones fits into 10? That's one way we can look at that. How many units will go into the number 10? Well, I know that it takes exactly 10 units to make up the number 10, right? 10 ones makes 10. 1 times 10 is 10. So I know that 10 is 10 times bigger than 1. Now, if I look at the next column, so if I move from the tens to the hundreds now and ask myself the same question, how much bigger is the hundreds column? If I move to the left again, how many times larger is this column going to be? How many tens go into 100? Well, I know 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's 10 lots of 10. So again, I know that 100 is 10 times bigger than 10. And it looks as though each new column is going to increase by a factor of 10. So we're going to multiply the previous column by 10 and we get our new column. How many hundreds go into 1,000? Well, 100, 200, 300, 400, 500, 600, 700, 800. Now I've got 9 hundreds, which is 900. And finally, one more. That's 10 lots of 100. That takes me to 1,000. So I can see that again, 1,000 is just 10 lots of 100, isn't it? It's 10 times bigger than 100. 10 times 100 gives us 1,000. So as I move to the left using my decimal notation system, I can see that each new column is 10 times larger than the previous column. And as I move to my right, it's very similar, but we just have to remember that as we move to the right, we're actually getting smaller, not larger. So we're guessing that it's going to be 10 times smaller. And let's just double check that. If I'm going from ones to tenths now, well, a tenth, by definition, that's just going to be what we get when we cut 1 unit up into 10 even parts. So if this is 1 unit, let's just say that's 1 unit. And I divide that unit into 10 even parts. Now I'm looking at a fraction. I'm going smaller than a unit. It's divided up into 10 parts. 1/10 is just going to be one of those parts. So this little part here, let's colour it in so we can see very clearly. That's 1/10. And I can see 1/10 is 10 times smaller than a unit. So if I want to go from ones to tenths, I actually need to divide because I'm going to the right instead of the left now. I'm going the opposite direction, so I'm getting smaller, I'm dividing. I'm cutting it up into smaller pieces. And if I wanted to go to hundreds, this is a little bit more difficult to represent, but let's just say that we are now going to zoom in on this tenth, and we're going to have to fit 100 pieces into the unit. So that means we actually need to divide the tenth up even smaller. And you can kind of visualize, if I need 100 pieces in the whole unit, then I'm going to need to divide each tenth. Oh, that is a very wonky line, but it's all right. This is just a sketch. It is not accurate. So these should all be the same size if I was using a ruler. So each tenth is going to need to be divided into another 10 pieces. So even smaller. 10 smaller parts. This is a terrible drawing, but you get the idea. So if I now divide that tenth up even smaller, you can see that I'll be able to fit 100 of these parts in the whole unit. So if I wanted to show 1/100th now, one of these tiny little parts is 1/100th. So it's so tiny. I'm just going to have to adjust my pen thickness again. That tiny little part there is 1/100th. And I can see that that 100th is 10 times smaller than the 10th, right? Because 10 of them will fit into 1/10. So again, we're dividing by 10 here when we move to the right. So what that tells us is this number 10 is very important to our decimal system. As we move to the left, one place value to the left, we actually are increasing the size of that place value by a factor of 10. So it gets 10 times larger as you move to the left. As you move to the right, we're decreasing the size of that place value by a factor of 10 again. But this time it's getting smaller, so we're dividing by 10 as we move to the right. So that's actually going to be really helpful for us when we want to multiply by 10. If I want to multiply a number by 10, I just have to move all my numbers to the left one. If I want to divide a number by 10, I just have to move all my digits to the right one. So I'll show you how that works. All right, so let's have a look at an example question now. So we've got question 1 here, which is 32 times 10. Before we start, let's just remember that as we move to the left from one column to the next column, so for example from 1s to 10s here, we know that we're multiplying by 10 when we move to the left. The next column will be 10 times larger than the previous column, and it's the same for every column. If you move from the 10s to the hundreds, well, the hundreds column is going to be 10 times larger than the 10s. And then the thousands, that's 10 times larger than the hundreds. Even from tenths, if we go from tenths to ones, if we're moving to the left, I know that 1 unit is 10 times larger than 1/10. And if you're moving to the right, if you're going backwards in the opposite direction, so if we changed this arrow around and we were going from ones to tenths, then we'd be getting smaller by a factor of 10, so it would be divided by 10. So let's look at our question, 32 times 10. Let's pop that number in and we might just represent it with a picture. So 32, that's 3 tens. So let's say that the red is tens. 30, that's 3 lots of 10. And the 2, we've got 2 units as well, 32. So that's our 2 units. Now we know that if we want to multiply by 10, we can actually just move everything over to the left. We can just move it one column to the left, Because if we follow this arrow here, we know moving something to the left is the same as multiplying by 10. So if I want to multiply my number by 10, I can move my tens to my hundreds column, and I can move my ones to my tens column, right? Because again, that's the same thing as multiplying by 10. So what number do I have now? Let's change that color back. 32 times 10, well, now I've got 3 hundreds, so that's going to be 300. I've also got 2 tens, so it's going to be 320. And I've got 0 ones, but I do need to put that 0 in there so I can remember that it's not 32, it's 320. And that's it, you're done now. There's also 0 tenths, but we don't have to write that unless there's a number here. So our answer to question 1, 32 times 10, is 320. And if you look at the number sentence that we've created, it becomes really obvious that when you're multiplying by 10, all you're doing is you're just adding a 0 on the end. So 32 times 10 is just 32 with a 0 on the end. Okay, so question 2 is very similar, but this time we're multiplying by 100 instead of by 10. And one thing that's very important to note is that 100 is actually the same as 10 times 10, isn't it? 10 times 10 is 100. So if we want to multiply something by 100, we can just multiply by 10 and then multiply by 10 again. So let's put our number in, 63.5. Let's stick to the same color code. So 63, that's 6 tens, 3 ones, and 5 tenths, 0.5. Okay, so if we wanted to multiply by 100, we just need to multiply by 10 twice. So instead of moving this over to the left one place, we're actually going to do it twice, to multiply by 10 twice. So we're going to go multiply by 10 again, and it ends up over here, 2 columns away. Same thing with the ones, times 10 again, that's multiplying by 100, times 10 again. And we can't forget to put our ones in. We can see that there's 0 units now, but that 0 is very important because it tells us the size of the other digits. So we end up with 6,350. And you might notice that what happened was the digits here stayed the same, but because all the numbers shifted to the left, the decimal place actually shifted to the right. And the numbers moved over 2 columns, so the decimal place moved over 2 jumps. So if we look at that closely, 63.5, and we move that decimal place over 2 jumps, this is now where the decimal place is. This becomes a 0, and we can see that it's 6,350.